Hey guys, I had some free time, so I put together this video to show you guys how to use the lab server. So, like, this is in the document, like the HPC, the high performance computing. This is one way to do that, and then later I'll talk about NSG. But yeah, so the first thing with the lab server is how to log on to it. So, basically, you got to SSH into it. So, the first step is to be on the VPN. So, like the Cisco uh, any Connect VPN. If you don't have this, you have to download it. Or if you're on campus, it counts, but it basically gets you on like the campus Wi-Fi, kind of. So then you can then connect to the server. So the first thing you have to do is actually like log into the server. So you do SSH and then your paul print, and it's at all this nonsense. And then you enter the password that's like associated with like your like MU account or whatever, and then you should be logged in. So I have this activated. So when you log in, it'll look something like this, and there's some like basic commands that you can know. So if I was you, I would like either write these down on some kind of doc on your computer or like a sticky pad by your like laptop or something, and then you can like reference them to remember them because there's a couple commands. They become second nature at some point, but while you're learning, it's probably best to just have them in front of you so you can reference them often. So the first kind of command, these are also like some of these are basic Linux commands that I don't know if you guys know or not. So there's ls, which will show everything in like the folder you're in. So this is like the main folder of the server for me, and these are all the different folders. Blue means it's a folder. So, for example, if I want to go into these tutorials, I can do cd, which is change directory, and then start typing a little bit of it, and then I can hit tab, and it will auto-complete the rest. And then I can do so cd neuroscience tutorials, and then you can see right here how this got added to the end of it, and that's just saying like, oh, you're in this folder now. So if we do ls and see what's in this folder, we can then see everything in here. So there's that. And then if you want to go back one directory, you can do cd and then like period period. There's a space in there also. So cd space period period, and you go out one directory, and now we're back here. And then once you get a bunch of stuff on your screen, it can be a lot easier if you do clear and hit enter, and then all that stuff will just go away. Kind of keeps everything clean and a bit easier to look at. But so the first thing you have to do when you're like running these models is you have to activate the lab server like environment. So this is save you some time having to make your own environment. So you can type source /opt/python bmtk bin activate, and all of those can be auto completed with tab. And you can see here python bmtk. So now we actually have like the environment like activated. So then the next thing we're gonna do is actually download the neuroscience tutorial. So I'm gonna remove the one I have here. If you type remove -rf and then like the name of the folder, you can delete a folder. So I'm gonna just delete this so I can show you guys how to download it. So if you go on GitHub, you can use the like the URL of the repo. So you can type git clone, and then this is the neuroscience tutorials that I had all of you guys clone, that has like the BMTK tutorials and stuff like that, and then .git, and then this then clones and downloads the repo. So then if we type ls, we can see it's right there. So then after that, you can do cd neuroscience tutorials, and you'll be in here. And the tutorial that I'm looking at today is called HPC tutorial. So we can do cd HPC, and then we're in here, and we can see what's in here is we have these batch files, which I'm going to go over, and then we have the this builds the network, and then we have some other stuff associated with the network that you might be familiar with from all the tutorials. So the first thing we're going to do is actually just build the network. So you can do that two ways. The way that you can do on like if your model doesn't take very long to build is you can do Python, which is going to like run Python, and then build network.py, and then this will run pretty quick. And if we see here now, before there wasn't this network folder in here, and now there is. So the network got built successfully. But sometimes it can be helpful to run this on batch. So basically, what that means is that the lab server will run it kind of like in like the background. So for example, some networks that we have take like a really really long time to build. Like one of the ones I'm working with right now takes like 3 days to build. So you'd have to be if you run it this Python build network.py like we just did, you'd have to be logged on to the server for 3 days straight, and like your laptop had to be on for all that and stuff, and that'd be really inconvenient. So if you run it on batch, it you can log off the server and your run will continue to run. So that just allows you to like, I don't know, it's a lot nicer for like waiting around and stuff. You could log off of the server and come back later, and your work will still be running and stuff. So to run a batch file, there's a couple batch commands to go over also. So there's sque, and you can see right here I have 2 things right now running on the server, but this basically shows all the jobs right now running on the server. So then you can also do other things like if I wanted to cancel one of these jobs, which I don't, this one's been running for 3 hours, you can type s cancel and then the job ID, which is right here. So if I wanted to cancel this job, I could type s cancel space and then that job ID, but I don't want to cancel it. But yeah, just some commands that are helpful to know. Get rid of some of this. So if you want to like send the batch file, so we can just look at the batch file here using vim. The build. This is what it looks like. Basically, this is just saying I'm going to use one node, and on this one node, I'm going to use one core on the server. This is what I'm going to call the job. This is the time limit I'm giving for the job, and then this, same command I ran earlier, Python build network, and then all of this is going to send an email to my email when it's actually done being built. That can be helpful just so you actually can, like, sometimes you might not know how long it would take to run, so then you can just get a quick update for like how long it's going to take. So that's pretty helpful. So if you don't know how Vim works also, to get out of Vim, you have to hit escape and then colon and then Q and then enter, and you'll log out of Vim. Or if you made a change, you have to do escape colon and then WQ. That's write and quit is what it kind of stands for. I don't know if you guys know how Vim works at all, but yeah. So we can just get rid of this network, and then we can run on batch. So we type s batch and then the name for a batch file. So batch build, and then you can see it really quick. The job is running HPC build, and then it's running for 2 seconds, and then if I do this again, you can see it's gone, and the reason it's gone is because it's done building. So we can see that here, that there's a new thing called HPC build.out, and we can view what that says, and it says we're done building the model at this date. So lowercase q. So like the model's actually done being built, and then if I go ahead and check my email, I can then see that this actually got this email says the tutorial is done building, so that's gonna be helpful. So then the next thing you want to do is actually run the network. So we'll look at the batch run file, which is going to run the network, and this is once again using one node, which is all you're ever going to use in the lab server probably. And this n of 50 means we're going to use 50 cores on the lab server, and we're going to call the output run, HPC run.out. I gave a time limit of 30 minutes. This will take like a couple seconds to run, and this command right here, this is basically just what allows us to run the run network with 50 cores, and it's like in parallel, so it speeds things up a lot. And then this, similar to what was on the last one, is this part right here is going to say when the model started running, finished running, and then it will plot the output of the model, which can be helpful. And then it can also, if you made any changes to the models, when you start tuning models, this is a really helpful thing. Of when you start tuning things, it will then print out the differences in the synaptic weights and stuff like that. So that might make not like a whole lot sense right now, but like once you get in the tuning networks, you can see how having a printout of what you changed can be really helpful. And then I'm sending this to my email, and then the Python plot is going to make this file called raster.png, and then it's going to attach to an email and send it to me. You can also attach other things. You could attach like just like the data itself if you want to like work with it on your computer, or you don't have to do this email stuff. I just find it's nice sometimes. If I like know what I'm looking for in a model, I can just quickly look at my email, and instead of having to download the data or download the plot or something like that, it can be a bit faster. So do Q to quit out of here, and then just to run it the same way we built things. So s batch type s batch run, and sque or I guess SQ, and then you see it's running for a second. It's been running for 9 seconds. It's gonna run for like something like 20-30 seconds. Won't run for very long. You don't have to keep updating it like this. I just want to see when it's done. It's 22. But if we look, you can also view if you want to like know how far along your model is. So we can look at the HPC run.out. So run.out. Oh, I didn't compile the mechanisms. I forgot about that. So you have to compile the mechanisms. So cd components, mechanisms, mod files. Yeah, so now that compiles the mechanisms. You always have to do that once when you download a model off of GitHub. You have to recompile the mechanisms. Something I just forgot. So the command for that is nrn-iv-modl. So you have to first navigate to where the mod files are. So in this, it's components and then mechanisms. And then you can see now there's this x86-64 folder. If you ever need to recompile the mod files, you first want to delete that folder. So remove -rf and then the name of the folder, and it will delete everything, and then recompile. You shouldn't really need to recompile things unless something really weird went on or you're changing mod files, but that's just how you go about doing that. So now I'm going to go back to directories. So I'm leaving the mechanisms, and then I'm leaving the components folder, and now I'm at the HPC tutorials. And then you can actually see that this job right here is still running, but like it's not actually doing anything. It's just using 50 cores, and it will until the time limit runs out. So that can be really annoying. If someone else was trying to run stuff on the lab server right now, they wouldn't have any resources, like because you're using them. So I can go ahead and cancel this job like that using the job ID from here, and then you can see that that job's gone. And now let's try running again. And now this time we can look at the out from it, and you can see it's actually working this time. We're running Neuron with 50 cores, and we're doing all this stuff, building the connections and stuff, and then look at it again, and it already went through the whole thing, and it's done with the model now. And then it's gonna run for a little bit longer. I had it I set it to run a little bit longer than it's supposed to, just so I could do, show you it's still running. But then, so this model ran in 6 seconds, and then it's going to take the email, like take the raster that it generated, the raster.png, and send it to my email. And then bring over my email. It then attached to raster. And this is what we were like, it's what it's supposed to look like. And this means that the model actually successfully ran right. And yeah, um, so now it's just a little tutorial over how to use the lab server. I'm also going to do one here in a second over how to use NSG, but I might just cut away and then bring that back. So yeah, hope that was helpful. All right, so now I'm gonna demonstrate how to use NSG, which is just another way of getting like a bunch of cores to run models on. NSG is really nice because you can actually get like way more cores than a lab server can, but it's a bit more finicky to run sometimes, and since like we don't directly run it, you have to like go through like a web browser and stuff like that to do it instead. But I'm gonna walk through that. So the first thing you have to do is you have to build the actual model on your computer. So what I'm gonna do is I have a terminal open here, and I'm gonna go to the neuroscience tutorials like folder again. So doing the CD again to change into that, and then I need to go into the HPC tutorials. So then I'm here, and then I need to build the network on my local computer. So build network. It says this shouldn't take very long. So yeah, already done. And then now that it's built, you actually have to zip up the file, and then you upload it to NSG. So to do that, let's bring this over here. I think it's very similar in Mac and Linux. I mean, or like Windows. I'm on a Mac. So what you can do is you can click on it and then hit compress. Or actually, I'm gonna there's a bunch of folders in here, so it might be better. I have this from last time to just compress this folder itself, just so you don't have to have all this stuff in here. Better just to have this. This would confuse it a lot. So just compress the HPC tutorials. So there we are. And then we're gonna go over to the web browser, and we're gonna log into NSG with username and password that you like gave them. So you do have to get an account on NSG, and you can apply for it if you don't already get one. So this is what it will look like when you first log in. So you should create a new folder. I have folders here for all of the projects that I've been running on this, and then the test I did. So you can just call it whatever. So I'll call it this. Probably shouldn't have the same name. Test 1. So I have this folder. Now I want to upload the data that I have. So you can just call it whatever, model. And we're going to go and we're going to browse to where that zip file was. So for me, it was on my desktop. And then neuroscience tutorials, and then HPC tutorials zip. So you have to upload the zip, and then you save it, and it will upload. So we can see it's right here. And then to actually run the model now, you can go to tasks, and then create new task. Call it whatever. Running BFTK model. Select the data that you just uploaded. And then you can go to select tool, and the tool that we're going to use is going to be called Neuron on Expanse 8.0.0. This is the one you're going to want to use, so you just click on it, and now you have to change some of the parameters. So just click on those, and the first one you want to change is if your code is in Python, which ours is. So you click this, and then you have to change the name of the file. So the file that we're going to be wanting to like run on the server is just the run network file. And so basically what I'll go through what each of these things mean just for clarification's sake. Maximum hours is supposed to run. So when you're running these jobs on NSG, you're submitting them to a supercomputer, and the supercomputer is used by like thousands of researchers across the United States. And your goal is to basically get the resource that you need so your model runs really quick. But if you request too many resources, you have to wait in a long line to like get those resources, and it can take a while to actually get the resources that then run the model. So you do kind of, at first pick this number pretty arbitrarily. This model that I'm running right now will take no time to run, so 30 minutes is fine. jobs that have a maximum hours to run of less than 30 minutes queue faster than other jobs. So if you can get away with it, it's best to have this number as low as possible. So for us, leave it now the same. Um, we do require mod file compilation. So that's what this thing does. So keep that checked. We already went through what this is. Uh, you can ignore this part right here. Don't click anything with that. We can ignore these, and we're just going to go to enter the number of nodes. So each node, you can see here, it has it filled in for one node. Each node is 128 cores and 248 gigabytes of memory or RAM. So if you need more, so like right now it's set up to use 128 cores. If you wanted to use 256, you can change this to 2. That's pretty overkill for the model we're running now. But later on, when we get like really big models, you can use 300-400 cores, and that'll just speed up the process of running the model, so you don't wait as long. But for now, we'll keep this as 1. We'll keep all this stuff standard, so we're just going to use 128 cores and 248 gigabytes of RAM. That's all fine, and then you can just hit save, and you can say save and run task. And it will just upload it now, and now it will start to submit the job and take some time. So I'm gonna just pause the video and come back when it's ran, because even though this model won't take very long to run, it has to be like staged. So like NSG has to submit it to the supercomputer, and then they have to talk for a little bit, and this can like basically what's going on their end is they're creating those batch files that we use on the server, but they're kind of creating them automatically, and that takes some time and stuff like that. So just for now, I'll just stop this video, and I'll start it again when like the job's actually done. So yeah. Okay, so it's all done now. It also will send you an email when your like NSG thing is done running automatically, kind of like what we're doing on the server. So that can be handy, especially if you're running like a very like large complex network and you're expecting it to run for 20-30 minutes or something like that. It can be handy just to have an email that says when you're done. So we can just click on view output here, and you don't need to worry about any what this is. You just want the output file, so we can download it, and it would take a couple seconds to download. And I'll just put it right here, and we're gonna unzip it. So we have this output, and I'm gonna go ahead and get up my terminal window again. So there we go, and I'm gonna go to desktop and then into output, and then I'm gonna activate my Anaconda environment, so I can this is the environment that I have all of like my BMTK and stuff installed on. So let's call it Neurolab. So we're in this output here, and we're gonna go just into the HPC tutorials. So and August, let's see, August, the raster that was in there. So there's nothing called raster dot PNG in here anymore. So now I can plot, and it will take the output that was generated like from NSG, and then it will plot it. So we can see raster.png, and if we just go into this and click on it, we can see that it ran, and it looks the exact same as what was ran on the server and stuff. So yeah, that's how you run on NSG. It's a lot less commands and stuff like that from running on the server. So yeah, that's just another way of running models. Yeah, there you go.